Hello class, welcome to Unit 11 Video 4. Today is the last video of Unit 11. So we have done arithmetic and geometric sequences. The last video was on arithmetic series, and so that means today we are on to geometric series. Your learning target is that you can find the sum of the geometric series and that you can use sigma notation. So we looked at sigma notation the other day, but just to remind you, it's the summation symbol. This is the summation symbol using sigma notation. So remember, geometric means that you multiply by the same number or divide by the same number to get the next term. Okay. So suppose you mail a joke to 3 friends on Monday. Each of those friends send the joke on to 3 of their friends on Tuesday. Each person who receives the joke on Tuesday sends it to 3 more people on Wednesday, and so on. How many people have read it by Friday? All right, so on Monday, you send it to 3 friends. Then on Tuesday, those 3 friends each send it to 3 more friends, so times 3, which gives us 9. By Wednesday, those friends go ahead and send it to 3 more people each, so 9 times 3 is 27. Thursday, 27, those 27 people each send it to 3 more people, so 27 times 3 is 81. And by Friday, 81 people send it to 3, so it's 243. So I am multiplying by 3 every time, which makes it geometric. The way currently it's written, it is a sequence. Okay, however, if I take and add all of them together, once they get added together, that makes it a series. So when I do this, it equals 363 people. Okay. There is an equation that you can use to figure out a geometric series. It is S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. So in this case, my a sub 1 is 3. That's how many people I start with. I would have 1 minus the ratio. What's happening every time? Timesing it by 3. To the n, how many times is it happening? 1, 2, 3, 4, 5. All over 1 minus 3. Okay. When you calculate this, do what's in the parentheses first. So it would be 1 minus 3 to the 5th which gives us, it should be a negative, negative 242. So I would have 3 times negative 242 over negative 2, which gives us 363. Okay, so this shows you can either use the equation or you could go ahead and write them all out and solve it. So here are our equations. You have 2. This is the one I just showed you. Here is another option. Once again, notice here you just need r and your a sub 1, okay, and your n. This one you need your first and your last term and your ratio. So depending on the information that you're given, that will decide which equation you need. Once again, you're going to need to know these for your quiz on this unit. All right, so let's go back to that. Find the sum of the geometric series for which we have a sub 1 and a sub n and r. So I have more information for this one, so I'm going to be using s sub n equals a sub 1 minus a sub n times r over 1 minus r. Let's plug it all in. We are finding 1,000 minus 125 times r, so times 1/2, over 1 minus 1/2. Okay, so I would have 1,000 minus 125 divided by 2 is 62.5 over 0.5. 1,000 minus 62.5 is 937.5 divided by 0.5 gives you 1,875. So the sum for that geometric series from 1,000 to 125 is 1,875. Okay, example 2. Maria arranges some rows of dominoes so that after she knocks over the first one, each domino knocks over 2 more dominoes when it falls. Okay, when it's 2 more, so that's telling me my rate is 2. If there are 10 rows, so that's my n, how many dominoes does Maria use? Okay, we also know our a sub 1 over the first one. She's starting with 1 domino. She's knocking over 1, and then each one is doing 2 more. So I have r, and I have n. So right away there, I know I need to use this equation. So we have S sub n is equal to a sub 1 minus r to the n, over 1 minus r. All right, so let's fill it in. So S sub 10 is equal to 1 times 1 minus 2 to the 10th, all over 1 minus 2. Okay. 1 minus 2 to the 10th is negative 1,023. And if I multiply that by 1, I still have negative 1,023 over negative 1. When I divide, I get 1,023. So in 10 rows, she would use 1,023 dominoes. Okay. Just to point out, if you wanted to write this one in some sigma notation, which you may be asked to do, we would be starting with n equals 1 all the way up to 10. Row 1 to row 10. And then, just to remind you, how do I write this equation here? Well, it's just your sequence equation. So in this case, it was our a sub 0 times r to the n. So what would my a sub 0 term be? Well, my rate was 2, so I was multiplying everything by 2. So you take your 1 and divide it by 2. So it's 1/2 times the ratio 2 to the n. Okay, so you know, this is how you could write this out into sigma notation, and you still calculate it the same way. All right. Example 3. Contagious diseases can spread very quickly. Suppose 5 people are ill during the first week of an epidemic. So we're starting with 5 people. So a sub 1 is 5. And each person who is ill spreads the disease to 4 people. So our ratio is 4 by the end of the week. By the end of the 10th week, so that's our n, how many people have been affected by the illness? Okay, so I want to know how many people have been affected by the illness. I have a sub 1, my ratio, and n, so I'm going to be using this equation. So S sub n is equal to my a sub 1, 5, 1 minus our ratio, 4 to the 10th, all over 1 minus 4. What I get here is 5 times 1 minus 4 to the 10th is negative, it's a big number, 1,048,575 divided by negative 3. And when I multiply, I get negative 5,242,875 over negative 3. And when I divide, I get 1,747,625 people. So diseases spread quick, and this can be modeled here using our geometric series. So in 10 weeks, this is how many people will be affected by the epidemic. Okay. We're going to be moving on to the back side of our notes, and we're going to be doing 2 more sigma notation examples. Okay. So here is our sigma notation. Sigma or summation or sigma notation is a convenient and simple form of shorthand used to give a concise expression for a sum of the values of a variable. Okay, so we always start with this value, the bottom one, plug it in. That gives us our first term. And we sum and go to the top value. So we go up to this one. This one gives us our last term. So this is summation or sigma notation. And in order to get those, remember you just take it and plug n in. So 1, plug it in for n. All right, so I look at example 4, and I know that this one is a geometric series because it is in the form a sub 0 times our ratio to the nth. Okay. If it looked like a linear equation written here, I would know it is arithmetic. So when I have this, I can figure out, well, I know n, and I also know my ratio, and I could also figure out my a sub n because I would plug in 5. So in reality, I can use either one of these equations. Okay, I'm going to go ahead and use this one. It's one less step because I already see what r is, and in order to use this one, I would have to plug in a sub n. Okay, so a sub 1 is, when I plug in 1, would have 2 times 3 to the first. So 3 to the first is 3 times 2 is 6. Now let's go ahead and figure out, well, what is n? Well, to go from 1 to 5 is 5 terms, and my ratio is listed. It's 3. All right, so this sum is our first term times 1 minus r to the third, or sorry, r to the n. So 3 to the fifth all over 1 minus 3. Okay, 6 times 1 minus 3 to the fifth is negative 242 over negative 2. So when I multiply 6 times negative 242, I get negative 1,452 over negative 2. And that leaves me with 726. So my sum of the first 5 terms is 726. Once again, as I explained in the arithmetic series video, if you forget this equation, guess what? Plug in 1. A sub 1 is equal to 2 times 3 to the first, which gives us 6. A sub 2 is 2 times 3 to the second, so I would get 9 times 2 is 18. Figure out a sub 3. 3 to the third, 27. 27 times 2 is 54. You can figure out a to the fourth, a to the fifth, and then add all of these numbers up, and you should get 726. I would recommend doing the same thing. Okay. Example 5, it says find n equals 1 to 4. Okay, we have 5n plus 7. This one is not geometric, and it is not arithmetic. So I cannot use any of the equation I was given. So what I need to do is just figure out, well, what is 1 when I plug in n equals 1 all the way up to 4? So this one is not geometric or arithmetic, so you just need to think it through. So I would find a sub 1. So it's 5 to the first plus 7, so that one is 12. A sub 2 is 5 to the second plus 7, so it's 25 plus 7, so 32. A to the third, or a sub 3 is 5 to the third plus 7, so 125 plus 7, so 132. A to the fourth is 5 to the fourth plus 7, so what's that? 625. 625 plus 7 is 632. So in order to solve this one, I'm just going to take 12 plus 32 plus 132 plus 632 equals, type it in your calculator, 808. And there it is. All right, that is the end of Unit 4, Video 4. And this is the last notes video for Algebra 2B. So, nice job, congratulations, and I will talk to you later. Take care.